Thank you. All right. Well, you interest me in a way that everything I say will just put me like lower the level down like, about myself. So, well, yeah, I'm working as a tech lead in a small team in TR right now. I used to work with Arman and at UNU, all the friends around here. Yeah, I just remembered my actual reaction about my first summer camp when I switched my career. I'm actually electronics engineer, like graduate, and at the same very summer, Arman and Mert was hosting a summer camp, and I was also really frustrated. Like, and that was like because I was coding since I was 12, and I thought I knew everything about coding and programming. Then there's a whole new area is just now happens beyond you, and you just unlock a new level, and you see there are horizons and horizons, endless things to discover, endless things to learn. So I think with this crash course, you're experiencing something similar. I think more intense because that course was actually more course of time. It was a longer period, but yeah, I think you've been doing really good job, like coping with your frustration and still being around here. So yeah, I will start. I'll go on with another frustration, which was one of the biggest problems with every developer. We end up saying it works on my machine all the time, but it's not the case. Or like when you want to show your work, when you want to share your work, and when you build a web application, you don't build it for yourself. You want to share. You want people to use it, and that's where it comes deployment. Like you need to put your code somewhere. That's like because you can't run your computer all the time, like 24 hours. Well, practically, like ideally you could, but it's not working out like that. You want accessibility. You want your software web app to be accessed by other people. So that's where it comes. The deployment idea comes in. You package your app. You put it somewhere. It's running all the time, and people can use it. People can access it. And while doing so, you want to remove the problem of it works on my machine. So you want it to work, right? For that reason, industry experts built some tools around that, and one of them is the containerization, which is coming with a tool called Docker. And today, we are going in a different method. We are fast forwarding, and I already set up like the Docker setup for you, and we'll be deploying this Docker containers to Heroku. So, and then after that, instead of building up, this time we'll be breaking down what we did. So we'll first make it real, make it happen, and after that, we'll break it down to how we actually did it, how it works. So I'm hoping that you all completed your Heroku, Docker, Git, all these requirements, and you already pulled the code base for the week 8. So you may end up having the same structure that I have. You can also open week 8 or just the root folder, GSCC 2019, also fine if you have it open. But I need a terminal which is in week 8. So if you are with me, let's proceed. If you have problems right now, ask some instructors, and they will catch up with.
So what we need for sure is to install Heroku and is to pull the code. Do we need to install Docker right now for this practice to work?
Yeah, because Heroku triggers Docker too. So let's maybe do some exercises to ensure that we all having stretching exercises. So let's say Docker PS. Have any response, or it says daemon is running or something.
What is the command?
Docker PS. I'm running it once more.
Docker PS.
Yep.
So
just
type Docker PS and see if you see anything. If there's an error, it will tell you that Docker is not a command or something.
Yeah, the worst case is Docker is not a command. The second case, Docker daemon is running something with daemon. So.
Yeah. Now, we won't have time right now to install Docker on your machines. but that's why we're recording this session so you can go over them. We're going to move forward with deploying our applications because that is very interesting. We want to show you how to deploy things to cloud in a real environment. So if you can proceed with us, that'll be great. If not, we will ask you to repeat this exercise at home with the video, because once you install Docker, you should be able to follow through with all the commands. And the next one after Docker PS is.
Yep. Now we have Heroku command.
Heroku.
And when you run Heroku, it should give some like help. If you don't get this, which means you have no Heroku CLI installed or is accessible. So another blocker. When you say
so we
Heroku,
just type Heroku and hit enter, and we see again something or an error. Heroku is not a command. Now I'm gonna do a show of hands. Raise your hands if you don't have these. Either one of them, Docker or Heroku. Raise your hands if you don't have these. Okay.
Guys, can you help us here?
What?
Instructors.
The teaching assistants. Okay.
Assistants.
Just a second. Again, especially if you're running on Windows, this might be tricky to set up. If you're running on Mac, it should be easier. We have the welcome guide. We have the steps to install Docker and Heroku in the welcome guide. We also posted the links to download Docker directly from its webpage in the Slack channel. So you can also have a look at there and download Docker from there. Try to set it up. If it doesn't work, again, that's fine. We're going to move on with our demo today, and then you'll be able to follow up when you install these on your machine. But maybe let's take this moment to talk about what Docker is and what Heroku is. We are talking about these names. Raise your hands if you don't know what Docker is. Okay, half of the class. Do the others know? Raise your hands if you know what Docker is. See, there's always this split. A couple of people who don't respond to any of the questions. Yeah, they're not like, I know or I don't know. They're like, I don't care. Another show of hands for Heroku. Raise your hands if you know what Heroku is. If you know what Heroku is. Okay. Now, raise your hands if you don't know what Heroku is. Okay. Still, some of the people do not answer any of the questions. I hope,
raise your hand if you don't give a.
I hope we're not very boring. I hope that's not the reason. So let's talk about Docker and Heroku. Docker is a company that is designed to solve the challenges of developers pushing things to production. Because so far what we have built in the 7 weeks is it is running on our machines. How do we put it live in a trustable way? There were previously many different ways of publishing our applications. They all sucked. None of them replicated our development environment. Hence, the term works on my machine, because it literally worked on your machine. But when you push the code to the production environment, to your real servers, it just didn't work. It crashed, and customers were complaining about it. And then people had the idea to create environments, special environments that you can replicate anywhere. And there is how we run our applications in production right now. Now, I think John will talk a little bit more in detail about this environment thing and what it actually means. But Docker is kind of a limited, contained, controlled environment where we run our applications. Heroku is another company. They try to make sure this production deployment experience is approachable by anybody, and it's very simple. It's a lot simpler than your regular custom production environment. It just works with Git push. If you have ever used Git push in this class, that is how Heroku works. You just do Git push, and your application is deployed to production so that other people can use. So these are companies and tools that are created to ensure we have a seamless experience when we release our applications. And Docker, again, ensures that our environment in our computers are exactly matching the environment of our production servers, so that if it works on your machine, it will definitely work in production. Obviously, this is an oversimplification. The reality is never that simple, and there are a lot of issues with it, but we're going to try to cover as much as we can during the lecture. So I just wanted to clarify what we're talking about, Docker and Heroku, so that you at least know that there are two companies, two different products to enable production rollouts.
Yeah. So shall we proceed, where I can talk about more about detail, those kind of topics? But if you're feeling ready, if the majority of the team is ready, we can just move on with Heroku. So right now in the, we're still checking out if you have the command. So the other requirement was to log into Heroku, but maybe you missed out. So if you say Heroku Login, well, if you want to check out if you already logged in or not, you can say Heroku, who am I? It should give you an email address, like your email address where you registered. Or if you don't get any response for that, you can say Heroku Login. So we'll log in together if you haven't logged in yet.
Normal insane. Did you get that email while you were 12?
Yeah, exactly. This like a side account. I was using Heroku, so I needed to reset password for this. So if you don't get any response for who am I, you can say Heroku Login, and any key will open up your browser or not. Well, this is interesting. This is the first time I've seen something. All right. So this is where you can log in. So after you log in, you will see a success page like this. If you haven't signed up, we cannot wait for this, but our assistants will help you out to move forward and speed things up for you. So I'm moving forward. So we'll go into week 8. And we have now here 2 different folders, back and front end. Last week, you ended up with having a front end inside the back end folder. So for sake of simplicity, I put them into different folders this time for this week. And we'll start with deploying backend. So we can go into backend. Can you follow up? Any problems with following up so far? No? All right. So there's a really silly part where we need to actually say Git init here, because Heroku works with Git repositories. So it needs Git to configure for configuration. That's something just we do. So you can run multiple times. It's OK. Just I just did it once more, so it's not a problem. And after that, we're going to create an application. Let's call it. So Heroku is a deployment provider where you put your applications there, but also this command line lets you create applications here. So you can say Heroku Create, and for this course, I'm starting with GSCC. You can give any name you like, but this has to be unique. So you just don't type what I write exactly, but put your, some imaginations into part. Like I don't know, I'm writing my initials and just random numbers, but just you have to remember this afterwards. That's all. And to make it obvious, because this is a backend project, I'm putting a backend here. So you should write something like Heroku Create, your name, and something backend, so that we will understand this is our backend. So I'm just running this. And voila, like now we have actually a deployment, but it's just an empty deployment right now. We can go and this URL and see what is there. Heroku, welcome to your new app. So we have an application running there. The only problem is it's not what we want. So we want our application there.
Okay, wait. Let's see if we could get this. Raise your hands if you saw that page. Heroku, welcome to your application.
Cool.
Just trying to make sure that we have at least a couple of people who can follow. Otherwise, that doesn't make any sense. Keep your hands up. Keep your hands up. All right. Now, you can put your hands down. The next question is, raise your hands if you have Heroku installed, but still didn't see the welcome your new app thing. All right, let's get that done. So we do Heroku Create and create a new project. And that is how we reach this screen. Just as a background information, you know, every week we give you some code that we prepare for you before the week. And this week we split the backend and frontend into two separate folders because they are two distinct applications. Backend is another application and frontend is another application on its own. And we're going to deploy them separately. That's why we put them into different folders. And we're going to be deploying them again separately. And we're going to be creating new applications for them in Heroku. Again, it's a, as John said, a deployment provider. So what you do is it basically gives you servers that you don't have to care. Now I asked the teaching assistants to be up and ready to answer any questions. Raise your hands if you need help. And maybe we can show that command again. Heroku Create and then a project name. Just make sure that is unique.
Well, you can't write the same one. It will just fail. And when you fail, you need to change the name.
We don't want people to fail.
Well, failing is okay. Like,
yeah, just put any name. Heroku Create something. And it is good practice to put backend in the end, because then we're going to be doing the same for front end as well, because we have two different applications.
So actually, what we have different here is this is different than your localhost 3000 or 8080. This URL you can open up in your browser and you can go to this URL and you'll have the same output. So this is the difference between running locally and actually deploying something. You can share this URL with your loved ones, your family, you know.
Yeah, if you want to show them that you can create an empty application, be our guests. This URL here is actually public, that everybody can access it. We do the same for front end as well?
Yeah, we'll do the same thing for front end, but before we publish our actual backend.
Oh, so so what comes next is the final moment. Okay, I see a couple of other screens who have this set up. That's perfect. What comes next is the pinnacle of our achievement. We're going to be deploying our backend applications to a real server, and it will be accessible from your phones and from everywhere else. So let's do that.
I'll just show the backend folder here. So this is the same backend folder you have been building for 7 weeks. There's only one different thing, it's Docker file, and we'll go into detail after we deploy it. So we'll first do it in a crash course way, then we'll break it down. So without going into more detail, I'll show you the same. We are in the same folder, same folder structure. Now we are going to run Heroku. Oh, what was it?
I don't know.
All right. I'll just have to check my notes here.
Isn't it git push?
No. All right. I'll just use the help. Yeah, container push. And there's one thing, tricky part here, because this is a web application, we are always putting web here. This is a special thing to Heroku. If your application is a web application, it's going public, you just put here web. So this will, all right.
Oh,
what happened here? Is this the same thing? No, this is a different application, right? So yeah, I'm in the backend folder, but you can see, because I've been trying out with Heroku, I have multiple applications around. So this is not the same ID here. No, it's, yeah. Yeah, there's one missing key here that, yeah, I just have to change Heroku. This is only a special thing for me. Sorry about this. The link? Well, I think you wouldn't.
Yeah.
Yeah, it should just work for you. So when
This happens because this is the 12th iteration of the matrix for John. He's doing this for the 12th time and deleting itself after he's done.
I just forgot to clean up this setting, so it should just work for you. You should be having the same thing. So the command is Heroku container push web. What? It's working? So if it's not working out for you, let us know. Yeah. No, like if you're not in the right directory, make sure that you're in the backend directory and you say git init there. So I will just show you the comments. Yeah, actually they are here. Docker push. Yeah. Again, sorry about this. These are the comments we are going to follow from now on. That is going to fail for you because we forgot under commit. Did you have the same error with this? Okay. Well, one other command we need to run, because right now Heroku is working with Docker, we need to log in with Heroku credentials to Docker. So please run Heroku container login before running this command. Okay, now you can rerun it. After logging successfully, you'll be able to push the image. Did you get the login succeeded output? Perfect. Cool. If you haven't tried it and perfect. So this was a one-time thing, like login, and it's easy to forget about it afterwards. Yeah, exactly. Now we can say Heroku container push web, just like the way it is here.
We still get an error, no images to push. Maybe we need to build the images.
But this is already building. So maybe you are not in the week 8 big backend folder. Okay. There's supposed to be a Docker file in the same folder. If you list the files, there should be a Docker file. Yeah. Yep. Exactly. You can say that, run the command, and deploy your command. All right. So there's one thing I want to show you. So you should be in the backend folder, and you should have run git init inside that folder. And before creating the Heroku, you should be logged into Heroku. So this is also in the README file. You can follow up after the course with explanations why we are doing this, what does it do. Yeah. Yeah. So because they are two different, like we behave them as two different applications. You can have like a big application which has front and the back end at the same time. But because they are the way they were built, like Vue.js is a complex application. If you cannot bundle up like a complex application with another application, I mean you can, but it gets complicated now. That's why I choose a path to deploy them separately. So once you change something in your front end, you don't have to change the backend too. They are independently deployable. So which gives you a freedom of like I don't know. Exactly. Yeah. Generally, the more separation is better. Like you can work with multiple people. So yeah, exactly. So for that reason, I also wanted to show deploying two different applications. If you're only doing one, sometimes it's also, hey, how do we do two? Then like, it's a bit more complicated than one, obviously. But if you put them in the same, on the breaking down part, it will be much harder to explain. So after you successfully push the image, it actually does the Docker build and Docker push for you. And what pushing means, your image is actually now stored somewhere in Heroku's repositories. So they keep your image, keep your application for you. And as the last message says, now we can release it with the container release command. So we are going to release it. Has everyone already pushed the image, or is it in still progress? You're done? Any problems so far? Lots of problems, I suppose, but so is anyone facing problems with the last step? So I'm moving forward. So we're going to release it now. So just showing the last screen. It's still the same application, which is the like placeholder application. Now after our release, Heroku container release, and I'm going to say once more web here. So this is our web application. We are going to release our web application. It's backend and the web application. So actually, it's just this. I'm just going to refresh this page. I'll go back to the comment after I see refresh page. So this is the same thing that you were actually receiving on your localhost when you run the backend app. Hello, a nice warm hello. So it's just as this. Now we deployed our backend application. Actually, we have another problem here. Can anyone guess what the problem is right now? Because on your local, when you run your backend application, you could get the hello, but some parts may not work, like what we are missing here. Do you think of anything will not work with our deployment?
Wait, what?
So we deployed our backend application, but there's something missing. Exactly. We don't have the data.
Data?
We don't have the database.
We don't?
Yep. So
wait, just make sure that everybody has that application deployment. How does your browser look like right now? You have the hello. Let's make sure everybody has this hello. Everybody who had Heroku installed anyway. Let's make sure you all have this hello, and then we're going to move forward.
So if you are copying, pasting from the README file, please replace the dollar and in curly brackets user with just a name, like maybe your name, like something, something. Yeah, exactly. So I just put as a like replace this template. So please replace the dollar user template string with something. All right, then let's move on. So we could also have some exercise for replacing some text, but this will just work out like when you change something, you will just run container push and then release, and it will just work out. Because that's the same command that you use for updating your code. Now, because as one of our students mentioned, we don't have the data yet. And when I go to person /all, you don't have to go because it will crash your app because there's no database. So one more command we are going to do is setting up a environment variable. Maybe I should have just skipped that part with AutoMagic or something, but this command is available here. And I'll just also paste into Slack for your convenience. And also putting the password here of your base. So I would also like ask you to replace this with your name or something. So your name here. If you're going to stick with the your name here message, you'll be sharing your database with other people who didn't change this message. If you're fine with that, you can also go with this way. So I'm going to copy this command and run in my terminal. I'm just showing it once more. It's Heroku config set, MongoDB connection string, and some gibberish. This is a database instance available for you because like deploying your MongoDB to Heroku is actually with a plugin. So you have to enter your credit card details, like payment information. So we just skip this part for now. But if you're serious about your business, you can also go to a Mongo Atlas where I created this. I will also include the links to that. And you can also use it for free of charge. And after the course, I will add some instructions how to do that. So
we want to give you a cloud-enabled MongoDB database. And currently, the only way to do that without getting your credit card details is what we did. We created on our own a MongoDB instance, and we're sharing the URL with you, much like we did in the MongoDB course. That didn't work at that time. We had a very hard time making it work. This time we prepared this in weeks in advance, and that's why we have the MongoDB connection string. Hopefully it will work for all of you. Heroku has MongoDB. You can get other MongoDB instances in any cloud provider, but they all either try to charge you or at least ask for your credit card details. And we didn't want to put you through that hassle for this course. That's why we set up a MongoDB on our own and sharing the links with you. In your real application, obviously, you would go through those steps and have your own MongoDB server. We're just cutting some corners here and giving you a shortcut. So this is a shared MongoDB instance, MongoDB database that all of you will use. So you can pretty much access any of the databases in this class. Just by changing the your name here part, you can access other people's databases and mess with them. Don't do them before the graduation next week. And that's why your name here should be a unique string to you so that there's no collision with other students. And when we do this MongoDB connection string thing, we're telling our Heroku application to use this database, this specific database. If in the future you have another publicly accessible MongoDB instance, you'll be using that with this command. And if you do it inside Heroku, it's even easier. That requires some be created, so we didn't want you to go through that.
So going back to my browser, it was showing this application error, and with a nice recommendation that you can see the error messages here. I'll not run this for now, but you can run it if you like. And I'll go back to my application. It still says hello here. It's really positive on the root. And let's see what happens with the person/all. Well, no one was fast enough to create any persons here. So I'll go with something in my history here. I'll create one. This is like the same commands apply here from the last courses. So I created a new one. I'm just refreshing.
Wow.
It's here. So what also you can do is if you feel like, in a sharing mode right now, you can still use the same your name here database, and you will see the same user in your application. So we'll be sharing databases. We are database friends. So in the same way, you can create meetups.
Just make sure when you're trying to create a person, the URL is correct. So John, if you can show that Axios post comment.
Okay. So this is a way to create a meetup. And this is a way to create a person. How's it going so far?
So
this is the complicated command that you need to run, and then
it is very interesting. You created your own applications and you deployed them to Heroku, right? To the cloud. If you use the same database, you can still manipulate the database for every single person who use the same database. So the connection string that we posted there includes your name here in the end, right? If you run that command, Heroku config set MongoDB connection string and that long string, and then go to your browser in your application, like your unique application URL, you're going to see the same people that we created because the database is the same, which is actually a practice that we always do in production deployments. We always have multiple applications, in fact, sometimes hundreds of them, having the same source code as you have right now, accessing the same database as some of you are doing right now with your name here, but serving different clients and multiple users. This is a way to scale our applications. And this is a prominent way of, Docker is a prominent way of scaling out applications. And we're going to be talking about that in a little bit as well. But effectively, if you use the same database, we are now impersonating a production setup with multiple computers. Think of Google. Think of Facebook. Facebook runs on thousands and thousands of servers. Machines like your computers have the same source code, have the same Docker images, or projects like you created on Heroku have the same Docker images, Docker containers, and they interact with the same database. As a result, they serve results through Facebook.com. So we're kind of replicating the same structure that we have in production right now with your machines. And if you use your own database, then obviously your applications will be different. Then you'll be able to create your own people and your own meetups. And in your homeworks, we're going to ask you to deploy your applications to Heroku. Hopefully, by next week, you'll be able to do that. And we will ask you to create your own unique database. Just change your name here to whatever your project is. And hopefully, we will be able to interact with your applications from the front end. And it's going to be super simple. You will have a backend folder and a front end folder. Just the steps that we did to push the images and then release the images, it's going to work. It's almost like magic, the way we will be deploying your applications to production. But this is basically your homework as well. You will have your own database. You will have your own application, not the one that we provided to you this week, week 8. You will have your own code there, your own project, and it will work with your own database.
So this is actually, we have now a backend up and running. It's with database, and thanks to some of you, it's also having multiple events here. But well, you can be creative and change the names too. I appreciate that. So one other comment I actually wrote here is if you're lazy to copy paste your application URL, you can say Heroku open. So it will open your application. So it goes to your application page. And if you say Heroku open people. Was it people? No, person. Okay, person all. It will just do the same thing, like if just showing if you're feeling lazy. It's nothing important. Then we can move on with front end if you like. So let's focus on front end now. I'm going one folder up, and there is front end folder just next to our backend folder. So we now officially switch to front end here. So we are in front end folder, and we'll be doing basically the same things. What is creating a new? What takes to create a new app is initializing an empty Git repository, because I will not do the same mistake this time. I'm going to remove my Git folder and say Git init. You don't have to remove it. Probably you don't have, supposedly don't have the Git folder there. But if you have, you can remove, and you can say Git init. You can say Git init multiple times, and you can say now Heroku Create. Now we're going to create our front-end application. So I want to stick with the same naming. I will just copy the name from my URL, which is this. DSCC 19, CKK 12, backend. I'm making this front end. Well, you can just use any name. It just have to be unique in Heroku. No one else should be having the same application name. But if you do this, you'll have your application. So I'll check out it once more. Heroku open, because I'm lazy. And it should show me, yeah, the placeholder application. So once more, we are at the beginning. We have an app, but we don't have a deployment yet. So we need, in order to have a deployment, we need to create an image, and we need to say container push, Heroku container push web. So the other part where we needed to container login was only one-time thing. You just have to do it once. So next week, or when you work with Heroku once more, you don't have to do it. This time, it should just build the application. So this time, our front-end app. And after that, it will start pushing. Wow. It even shares some of the cache with the other app. So it will be slightly faster than pushing your backend application, because there are some shared parts with our applications, but that's for the second part. I can tell that you started pushing too, because my speed just went down drastically. The code, the command is Heroku container push web. This command, this is the last command. But make sure that you are in front-end folder, and you said git init, and this Heroku create. So if you want to create a new Heroku application, you just go any directory, you say git init, and say after that git init, and then Heroku create an application name. After that, you have an empty application. And if you want to replace it, you just say Heroku container push web, and you'll have an image. And once you make sure that you want to deploy this, you just say, now we can release it with container release command. So Heroku container release web. So I'm going to release this application. Wow. Any problems so far with the front end deployment? No? All good? Great. So let's see what's happening here. By the way, because this is a free account, it's not fast as the paid Heroku accounts. So just let you know. Obviously, if you pay, they will speed things up. And one other thing, if you leave your application empty for, let's say, 10 minutes or something, I don't remember the exact duration, but your app is going down, and the next person who is opening your application will have to wait like 30 seconds or something. So it's not that Heroku is bad or something. It's just free accounts. They just take your application down for a while. When you visit the application, it takes a bit like booting up time. So, is there something missing here? I thought we had some events here. So some meetups. 4 of them should have been listed here. We don't, as far as I remember, we didn't list it like people here, but we should be listing or meetups here. So again, because there are 2 different applications, this time, again, we don't have the data. We need to configure our front-end application. Hey, this is the backend you need to use, because everyone is now having a different URL here. I'm like, this is CKK12 for me. You just end up with something else. So this time we need to configure our front-end application with pointing out where our backend is. So this is the command you need to run. Don't forget to replace this user thing, please. Are you following up? So this time I'm configuring my front-end application, saying that, hey, this is the backend you want to use. And this also opens up another opportunity. You can use other people's backends. So with the same backend, you can come up with different front-end applications. This is like public APIs there for creating different applications. So I'm also going to paste this command into Slack. Oh, thanks. Yeah. I'll just put my name here. Or you can replace your name or your name here. All right. So now, because I configured my front-end application now and it restarted, it should be able to get the meetups listed here. Yay. So now we have 4 meetups listed here, but because they are all the same, I'm just need to create a different meetup to show that it's actually real. Let's create for future. So I created 3 more here. And they are listed here. Any problems so far?
Okay, let's get this done. So we created a new application for the front end. We built the images for the front end. We deployed them, and we're able to see our records just as we did on our local. If you didn't notice, we're pretty much done. So our applications are online. And this is what you will need to do in order to put your applications online as well as including a couple of files in your projects. We're going to be talking about it in the next 2 hours. But we wanted to take this first hour to show you that we can achieve these things in about an hour, with just a couple of commands, we can deploy our applications to a real running cloud environment, and everybody can access those. So let's take a couple of minutes to make sure everybody who installed Heroku, who has Heroku, can get this. Raise your hands, and we're going to walk around and help you out. So I have the microphone for one lucky person to raise their hands and tell me what we did in the first part of the lecture. Who is that lucky person? No one? Again? I need one lucky person to raise their hands and tell me what we did in the first part of the lecture. It's always you. It's always you. I need someone else. No.
We deployed both our backend and frontend app to Heroku using Docker, and we connected the backend app to the database and the frontend app to the backend app.
Wow, amazing. Yes. Okay, I need another person to tell me what that means in human terms. Because that was, 70%, 75% technical words and keywords. What does this mean in human terms? Anyone?
We launched our app online for everyone to see.
We launched our app online for everyone to see. Yes, thank you. Great. Now,
That will come.
we showed you a couple of commands to run the current application that we prepared for you, which has certain configuration in it already there, done by John in the past week. So we first wanted to show you the end result. And now in the second part of the lecture, we're going to go into how you can do the same for your own projects. What you need to do in order to get your own projects online in Heroku. And we're going to reuse what we did in the first part. We're going to use the same commands again. But before that, we need to do a certain preparation to get to that point. And we're going to start now from scratch how everything all came together and what all of these mean.
Yep. Okay, so let's have a clean start. This is our backend application, all good backend application from the last 7 weeks, result of last 7 weeks. Basically, like if you go through the code base, it's familiar, it's the same thing. There are some minor changes happening over some files. For example, here we have a new change in this line, which allows us actually to configure the port. It was only 3000 before, now we can configure it. So what it means, configurable. We made our port configurable. How do you configure an app? You do these things by environment variables. This is what we did with Heroku config set. So you have an application, and you think of running this in some other place. So you have to think of it outside of your computer, because it's always you make sure that it works on your machine, but the unknown part is working on another part, like another machine. Is it going to work when I deploy it? So one of the concerns is making apps configurable for the environments you are going to put them in. For that, we also have these concerns, like npm install is required, right? Like when you want to run your backend application, if you go to, I'm opening my terminal if I can. No. If you go to your backend directory inside week 8, the way we actually run our application was npm start, right? Was it? Or we were using Node index.js, right? So now it says server listening. That's all good. But if you didn't have installed Node modules here, like I don't want to remove Node modules because it will take a lot of time to get it back. But if you hadn't Node modules here, it will just fail and you needed Node modules there. So there should be a way to specify what you need. Like, hey, I have an application and I need this, that, and that. So give me something which has Node.js in it, and I can run npm install there inside that machine. So there comes Docker file into picture, which is actually basically defines this. It's like actually like I don't know, a recipe, like you're preparing some food. It's your base. Like I need Node.js, and I'm working on this directory. There are some statements. Hey, add some salt, add some water, and just mix them, something like that. This is like your requirement list. When you are building your application, you define what you need there. So I'm starting from a base point where I have Node.js. So there are some already pre-built images. They are called images where you can start. So I'm imagining a world where Node.js exists. This is your starting point. And then you can start working there, which means actually cd, like I'm changing directory to this directory. And I'm doing some copy here. I'm copying my package.json, which lists all my dependencies. And I'm running npm install there. So there are some other details we can just overlook right now. After that, we need our all code base, copy it into that application. And our command is the way how we run it. So this is what we do. Node, actually, this can be same as Node index.js. So this is how we run our application. So this file itself tells me lots of things. This backend application is a Node.js application because it says from Node.js, like it starts with Node.js. And then it's working in an application directory, not very important, it's just arbitrary folder name. But after that, I'm copying my package.json because package.json is important. It keeps all your npm, like your dependencies or application dependencies. And then what we do when we first get an application, like get our dependencies, we say npm install, and then we copy everything inside. Maybe this is the copy part is not clear. This is like instructions on this directory. Question? Yeah, that's maybe I missed that part. This is like I'm imagining a new environment for my application. So this Docker file resides in the backend directory, but when I say this statement from, it starts like a new computer. It's like ordering a new computer. Hey, I need a PC, I need a Mac, and I need Ubuntu inside, or I need Windows, something like that. You say, hey, give me something as the basis. So this is like a clean environment for you. And this is because you want to specify your application's environment. So this comes from the term container. We are going to put our application in a brand new space, new environment. And we put everything only needed inside. And also the Docker containers are similar to everyday like food containers where the smell doesn't go out and make your fridge smelly. So if you put everything in containers, they will just be isolated inside. You encapsulate it's inside. So if you run every application in your computer, it's like putting your place into fridge without any lid on the top of them. So which makes like their smells mixed together, and we don't want that. We want clean, good stuff. So that's why we put ourselves our applications into containers, and thanks to this from statement, we can start with some bases. So Docker file is the instructions file, so it doesn't do anything by itself. But with a Docker command, we can actually make this happen and make it alive. So I'm going to start with some new terminal inside my backend. And right now in my backend directory, there's one simple command, Docker command, which is Docker build. This is actually what happens when you say Heroku container push. All right. Am I in the? Okay, sorry. A Docker build and there's a dot needed because this is the directory I'm working with. Dot itself points out the same directory. So this output, does this output look familiar? This is what we had here. So building web, sending build context to Docker daemon, and doing these kind of things. This is basically the same output here. So Heroku was actually doing some funky stuff underneath, running Docker for us, and doing some of the stuff actually for us. So we are now dissolving this magic around Heroku. Heroku did lots of things for us, but what it did actually running this Docker command. And you can see every line inside the Docker file is executed here. You can go and try out the same thing, and it will be really fast because it says from cache. It says using cache because we already built these applications. Remember, when we say Heroku container push, it built the container and then pushed to the Heroku repository for us. So we already did this, and it's using cache. For this part, there's not many interactive things taking part. So I'm just telling about what's going on. But if you have any questions, don't hesitate to ask right away. Yeah. Yeah, it's Docker build and with a space and after that. Yeah. Yep. Good. Yeah. Yeah, like while I was looking at it, I changed it. I just wanted to point out it's actually the same thing. Like I don't remember why I put this way, the same way, because it's like something in this directory, or like you can give the full path. It's basically the same thing. Like, this is how a container is created. So before going into running our container, there's a Docker example actually. Docker run hello world. So this is an example from Docker's getting started documents where you can ensure that your Docker is running. So basically it outputs some, I'll just run the same thing here in terminal. I have more space here. Docker run hello dash world. So it says hello from Docker, it's working great, and some information. And it actually shows another suggestion. You can run this, and you can go into that. So there's -it, some parameters. I will also explain what does that mean. Docker run. So I'm going to run similar command because we are in a we are sharing same Wi-Fi. I don't want everyone to install Ubuntu, download Ubuntu their machines. It will take lots of time and lots of traffic. And we can say just Alpine, which is much smaller image, but there's no bash, so we can switch to shell. And this IT means it's like we are running an interactive session. You just use IT details, like we can figure out details from documentation if you like. So you see, there's some stuff changed. It was like this, and now this is like that. So what I can see here, actually, I'll tell you one other Unix command. I will just write exit here. So I'm actually back to where I was before. So I was in a container, and I got out. And I will run just a really long outputted command. And you see there are multiple processes running. PS command is listing what processes are running on your machine. So, sorry? Yeah, if you want to figure out where you're right now, you can say PS, and I see that there are lots of applications. Obviously, this is a Mac environment. You can also figure out by listing here. It says like all these macOS style stuff. But when I go into a container, let's say an Alpine container, when I say PS, all the processes are actually very simple. There's only one root shell command, and the other one is the ps command that are just running at the same time. So this is where the isolation topic is coming from. So when you are inside the container, the only processes running for the system are two things. So it's like just like you have a virtual machine. There's also really tough question: what's the difference between virtual machines and the containers? Actually, they are really different, but it's really tough to explain in a short time. But you can just say that it's containers are actually sharing the same system resources, but they cannot interfere with each other. So you have some isolation, and your application will run as you expected. So remember, our biggest problem was it works on my machine, but it wasn't working somewhere else. It's for that reason. If you isolate your stuff, if you put them into a container, its smells doesn't go away. Like it doesn't rot other containers inside the same environment. So that's why we are putting our applications inside containers and create them as like a package, and then we push it, and then we deploy, and it just works like we expect them. Before containers, you just have to go to, I don't know, SSH into a machine, like, because you're not running your application on your machine, your working machine, working station. You need to go some server, let's say install Node.js and all these dependencies there, and then you run that. When you wanted to update the code, you just have to go to manually update the code somehow, and these things were taking lots of time. Just remember that how much time we had to deal with when we were installing MongoDB here, or Node.js, or installing anything at all, how long it takes. And just think that you want to do this in bigger teams, or you want to do this in, I don't know, multiple machines. You have to go to there physically or spend this time. But Docker makes everything easy because you have a instructions file, which is Docker file, and you just specify what you need there, and it just makes it happen. So, any questions? Okay. Yeah. Yeah. Yes. Good question. There are some Docker commands when you say Docker. I'll just say Docker, and it will list lots of commands here. I'll just visit some useful ones. Docker images is showing your images. So because it's a long list, I'll just say grep is just filtering my output, and I will just say GSCC maybe. Yeah. So you see my other trials. 35 hours ago, I started doing some stuff, and all these GSCC related containers are here. Some of them are 1 GB, and I try to decrease the size to 100 megabytes. So yep, exactly. So images are actually like blueprints of your application. Yes, because one of the instructions here is actually adding your code itself. So if you don't say this, for example, if you exclude this line, your code base is not included in the image. So images starting from scratch, and there's actually an image called scratch. So you can start from scratch for real, but we are starting with Node.js. So there's an image already pre-built in the image registry. So there's an image registry where these kind of things are kept. And you can say Node, and this is Node.js version. I want a Node.js version 12. And after that, you just type here whatever you want. And the copy command is actually copying this things from your directory. So because I'm in backend directory, it's copying the things from backend directory. The reason why I'm not copying the node modules here, node modules directory may contain some stuff that are specific to environment. So again, back to the same problem, it works on my machine, especially when you think of working with different operating systems, macOS, Windows, and Linux. Your application probably not going to work with the same way in a different environment, because macOS, for example, is case insensitive. You just name a file with different thing, and it will definitely not work in Linux environment. Same goes for Windows. So you just need to exclude node modules directory because it contains specific things for different environments. Yes. Yeah.
So when you change something in this source code, only the layers commands that change. So why we put the package listen, for example, because it changes less quickly.
Yeah.
So if you want to go and recall all the time, once again, just layer the instruction change for source code will be executed.
Well, that's a really good point, but maybe it's too much detail for now.
Yes. And if we don't repeat the questions, it won't end up in the recording.
Yeah. Okay.
Also, anything that we don't say into a microphone won't end up in the recording, which won't be really helpful
Okay.
for future reference.
Okay. Just saying out. The question was, do we need to rebuild every time a source, even if we change something in our source code? Just a simple change will also requires a Docker build once more. So this is package.json and npm install on top is about the best practice. We'll figure out. You'll figure out on the way. Right now we're skipping this because it's some kind of too much detail for right now. But I hope you can hear John's explanation too. So maybe I will give you a microphone so that
I get it.
And which command do I have to run in case I now change something, like to, because do I again Heroku Create, or is there another command that I'm using?
Well, actually, on the way I tried to explain some people about this. So it's only container push and container release. So Heroku container push, which is in README. I'll just show you the commands here so that. So because you already have an application, you don't want to create a new application. You just want to update it. You just need to say Docker Heroku container push web, which will rebuild. As you see, the output is identical to our Docker build command. And then when you push it, it will say that you can now release a new version. And when you say Heroku container release web, it will update your existing deployment. So there's a new version coming in after you make your changes.
And when you're working with Docker, it's just another Docker build command.
Yeah, like Heroku container push doing some Docker commands underneath. Another question. Okay. Can you pass it?
Is Heroku using Docker?
Yes. Especially the container commands are using Docker intensively. Like Heroku is like a set of tools, just make you deploy easily, because they have a business where you can put your containers, your applications in. They make use of Git and Docker to make this system work. How integrate?
How can we integrate with Git?
Integrate with Git, with Heroku usage, or you mean what do you mean by that? Integrate with Git?
To have when I'm deploying to the GitHub, I want to not use this path all the time.
Are you talking about continuous integration?
Yes.
So yeah, I know.
So every time you push something to the GitHub repo, you want it deployed to the production environment. You don't want to do it on your own.
I think that's a topic for the 2 weeks later, right?
We covered this in the past. There was, when we first did this course 3 years ago, there was a service called Docker Cloud, an offering from Docker, and it was super easy to get started with. You just gave them your GitHub repository, and you didn't have to type anything. Whenever you push something to GitHub, it would deploy your code and your application, and it would all work. However, they stopped that service. They deprecated it. So we had to find an alternative. And that means right now it's a little bit tricky to have that set up. We call it continuous integration. It is continuous, that it happens on every time you push something, or we call it continuous deployment more aptly. Every time you push something, it gets deployed to your production environment. It is a little bit more convoluted to set up. However, there are still ways to do it with Heroku itself, using GitHub Actions, and you can find more about it online. Unfortunately, it's right now outside of the scope of this course. There are other tools which you can use to make this happen. Yeah. So Travis, Bamboo, any other continuous deployment tool will work with this. But it requires further setup, and it's not really trivial. No worries. Another question.
Can you pick like a specific image to release? So let's say you want to pick a specific version of the image. Can you do that, or do you have to do a rebuild every time and then release that one right away?
That is a really good question, and I don't know the answer. Like, I learned Heroku just for this class, and I also wondered the same question. So I will share the answer inside Slack channel, or I don't know. I cannot figure out right now. It's too risky. But there's Heroku CI documentation. Like, Heroku's documentation is great, and you can check out further questions. But right now, if we can focus on Docker side more, because the first side of this class was about making deployment real, and we made it together. It's now about going back to the basics roots where we start from. So it's starting again from Docker. How can you Dockerize your application right now? And after that, I will move on with showing how can you run your Dockerized applications locally. So
did we talk about that word, Dockerization?
I said containerization.
Containerization and Dockerization, they're kind of like exchangeable. This is a trend that came up in the last couple of years. And you're going to see this in the industry, in blog posts, in articles, in job descriptions, knows about containerization or Dockerization or has experience with it. It means taking your existing application and putting it inside a Docker container, which is a great way, the first step to make it run universally everywhere. And that's why we use it all the time. So don't be confused when you hear that word Dockerization or containerization. It just means taking your application and wrapping it inside a container. And for that, we have the Docker file. Maybe if you go to the Docker file, can you rewrite it just to show the very minimum? What is the first, like the bare minimum of a Docker file that you need? It is from Node.
Yep.
It is copy your application.
Actually, random thing, like it's backend. I'm just picking some other example.
You don't even need backend. It's just copy dot should work, something like that, right?
It's root.
Yeah, that's fine. Copy the application, run npm install, and then how you execute it, right? Command node index.js.
So this is what we do when you run your application, right? You have a machine, actually it's implied here, and you have Node.js, and then you copy is just about moving context. So because you are outside of Docker, you're copying everything from your machine into a container, the isolated environment, and then you run npm install there. And then how to run your application, Node index.js.
So this is very, very similar to what we did in the past. With, this is what you do every single time before coming to the class. You clone the new files, like on line 3, copy dot dot. It is very similar to cloning the repository again, or fetching the updates. Then you do npm install to see if there are any new dependencies, to install those dependencies. And then you do nodemon or node index.js, whichever one you do. And that is how you run your application. This is exactly the same in Docker. And obviously, for those reasons, it is not the best way to run stuff in production. That's why we have the advanced version. Now, these 4 lines actually translate into a couple more lines. John, if you go back to the actual version that you had before,
yep.
This is pretty much doing the same thing in a better way. The differences are we specify the exact version of Node.js that we want to run. Otherwise, it always runs in the latest version, and sometimes you don't want that. Sometimes your code is incompatible with the latest version, so you always have to fix the version. Which version of Node.js are you compatible with? Are you running with? And then we first copy the package.json and package.json. Again, the reasons I think we're going to come in a little bit. And then we only install the production dependencies, not all the dependencies, because who needs ESLint or who needs development dependencies here? Like Ava. Ava is a development dependency. It is for testing your application. We don't need it in production. Hopefully, you tested your application before coming to this step. So we only need production dependencies. Yeah, those are the production dependencies. And then we copy the app. We expose a certain port, because that is where our application is running. Otherwise, we won't be able to access that application. And then the command is the same. So this is kind of like the best practice of building Docker files, which is very similar to the very easy version that I showed you. But hopefully, this makes it a little bit more clear on how to get up and running with Docker. It is exactly creating like creating a new machine. You have a new computer that you got brand new. You install Node.js and Git. Obviously, that is what the first line does. It installs Git and Node.js for us. Somebody did that for us previously. And then we say, OK, here's my files. Copy these files, run npm install, and run the application. We're doing that for Docker. And if we didn't mention it yet, Docker containers are like computers on their own. They actually think that they're real computers. They think they're real servers running in the cloud, like real machines with real hardware, real hard disks, real RAM. But obviously, we can configure any aspect of it, and they're not real machines, because real machines are very costly. We cannot afford them. So we trim them down into smaller bits. So it's almost like a placebo for computers.
Yeah. So any more questions about the Docker file? I will move forward to another example in the front end.
What other questions do you have for us? Is the way we ask questions. Please go ahead.
My question is related to the first one I did. So Heroku is using this Docker file? Exactly.
Yes. Heroku is making use of both our local Docker installation and the Docker file that we have.
So in this case, we don't have to use Docker. We only use Heroku because it's doing basically the same. I mean, Heroku is using Docker.
Because we're going to use Docker for local environment as well.
Yeah.
We want to make sure we're creating a new machine here. The same machine in quotes, the same machine that Heroku is creating and Heroku is using. So we kind of ensure that in our local environment, we have a dedicated machine, dedicated server for our application, which is exactly the same as the server Heroku has for us. So our code runs again, in a virtual environment, in a machine that is created by this Docker file. That is why we want to use it for local development as well. Up to now, you always used the Node installation in your own computers, right? What if you send your code base to another computer for another developer to work on, and they don't have Node.js installed? Do they have to install Node.js as well? Maybe you can say that it's not a big deal, but it becomes a big deal if multiple applications require different versions of Node.js, requires different configurations, requires Python, requires, I don't know, additional 10 software that you need to install to run your application. That is why we give them this template, this virtual server, this environment, this contained environment, this controlled environment, so that our application runs in it. This is what Heroku uses. This is what we want to use for our local development as well, because we want to make sure our local environment is identical to the production environment. Our local environment should run exactly as it would run in production. Does it make sense?
I think it comes with the same problem, like it works on machine, but not on deployment.
Yeah, exactly.
So,
we want to solve that problem.
Yeah.
Another question.
Maybe I missed it, but so if I want to continue working on your app, I pull your code and all that. How do I, because if I do need Node.js and whatever on my machine to run your application, so how do I run Docker on my local machine?
So you don't need to have Node.js anymore. Once you have Docker, that is the only requirement you need to run Dockerized applications. That is why it's a verb. If any application is Dockerized, find any application online that is Dockerized. You only need Docker in order to run them. You don't need any special software installed.
Okay, but is our application Dockerized already right now, or is it just this Docker for the
Exactly.
deployment?
Yes. Just by having this Docker file in it, our application is Dockerized.
So instead of, I don't know, starting the virtual environment and installing requirements, whenever I pull the code of a Dockerized app, how do I install the requirements then in my project?
We're going to come to that next. And there is another way of running multiple Docker containers or images at once, because we have the backend, we have the front end, we have MongoDB as well. Oh, that's a very good point. MongoDB. Now, in order to run all of your applications, you need MongoDB installed and running, right? But some of you in this class experienced, for example, when you're running tests, your tests don't execute. You have to wait for a couple of minutes and then they crash just because you forgot to run MongoDB. So these frustrations shouldn't happen at all. And we're going to present you a way to solve this. The tool is called Docker Compose. And Docker Compose brings together multiple Docker images or containers or machines, backend, frontend, and database in this case. And it always runs together, so you don't have to remember. You don't have to start them manually in separate terminals. You just have one command, Docker Compose up. We're going to talk about that. And then it runs everything for you. So you always have a running environment that has everything in it. And you're not missing out any details. It really helps, especially, for example, when you're onboarding a new team member. If your application is Dockerized, all they have to do is to get your code and just run one command, Docker Compose up, and everything works. Even if you have like 20 different applications, 20 different services, 10 different backends, 10 different frontends, it doesn't matter. Everything will run. Whereas if you don't have a Dockerized application, your new hire will have a really hard time in trying to get everything right in multiple windows, in multiple configurations. Make sure MongoDB runs before this backend comes online. You know, that sort of stuff. So these tools are really handy in ensuring your local environment, your local development environment is as clean as possible, requires minimal installation and minimal messing up. And, you know, it's hard to install MongoDB on a Windows machine. With Docker, you don't have to care. If you have Docker in your Windows machine, you can install any tool because it's not really installing. You're just using the machines that other people created for you. So it's a very convenient tool for you to use in your local development environment, which mimics your production environment. Does it kind of make sense? Okay, was that because you're bored? That was a very... Yes, please be done with this. Question? Okay, I'm coming over. Just a second.
Yeah, I just wanted to know, does it make sense somehow to use Docker for development purposes, like just for convenience, but to have all the ability?
Yes, it makes a lot of sense to use Docker for local development purposes as well. Because again, you don't have to have a specific version of a database. Like for example, at Wayfair, we're using MS SQL, Microsoft SQL Server, who installs Microsoft SQL Server on their machines? That is like, I don't know, that's not a very good software to install on your machines. So what we use is we use Docker for local development, and we set up our database there. Also for our code, we want to make sure that we don't ever have to think about will it run in the production environment. So once you set your local environment to work with Docker, you don't have to ever be concerned about the rest, that your application might not run in the production environment. You ensure that whatever locally works will work in production. So it is actually a very great way. I mean, we experience this daily. Even today, I had a problem with the local development environment, because in your local machine, you have some global installations, right? Some scripts that are global. For example, every Macintosh laptop has Python installed. In Docker, you don't have Python. In your production environment, you don't have Python until you deliberately install it. So one of my engineers in the team set up a new process within our application that uses Python that worked great on their computer. And when I installed it, it didn't work for me because I don't have Python. When someone else who was using Windows installed it, it didn't work on their machine because they don't have Python. You don't have to have Python in order to run anything. And if they use Docker and have that process within Docker, that would already install Python for them. So we wouldn't have to care to have Python on our machines. So it makes a lot of sense for software engineering right now to run everything you can in Docker. Are you running Jupyter notebooks? Run them in Docker. Are you running third-party applications or databases? Run them in Docker. Run everything you can in Docker. Develop all of your projects in Docker if possible. Obviously, the setup requires some attention, like having this Docker file right. Also, how do you get nodemon working inside Docker? Because we don't want to lose the capability that whenever you're changing a file, whenever you're saving it, your application should be reloading. That is what we have with nodemon, right? Nodemon watches our files, and whenever we change those files, that application restarts. How do we have this in Docker? I don't think we're going to cover that today, that part. John?
Which part? Sorry.
mounting volumes and watching file changes. No, we're not going to cover that part. Obviously, there are more advanced stuff with respect to Docker. We're just giving you the bare bones of getting started. But it's a great idea to develop everything in Docker. It is future-proof, and it is foolproof. So I'm going to stray a little bit off topic here. As software engineers, we have to design our systems as foolproof as possible, because we're going to act foolishly. And we want to allow everybody in the team that space so that they can't really make any mistakes. Everything is very, very foolproof. Even if they do mistakes, there's no big impact. Nothing will crash and burn. We won't lose millions of dollars if errors and mistakes happen. So we want to give everybody the room to make mistakes, which means we cannot really afford having very intricate, very delicate setups in our software. Whether that is in designing our application, in designing our objects, in designing their relationships, in designing our database, or in designing our deployment, we have to be as foolproof as possible. And Docker is a great way of achieving that. So your colleagues shouldn't be concerned or with how your application is running, how your application is set up. It should be very trivial for them to use, and it should be very trivial for them to change. It shouldn't break. You wouldn't like to hear, oh, that doesn't work on my machine, or that works on my machine, but that doesn't work in the testing environment. Or worse, it works in the testing environment, it doesn't work in the production environment. We had this a lot in the past, in like 5 years ago, 10 years ago, 15 years ago. We were copying files with FTP to remote servers that were accessible from the internet. And we manually installed and upgraded environment versions there. You know, if you have Node.js, we manually went into every single server that we had and updated the version to a specific one. You know, if you're using Linux for your servers, you have to make sure it is a specific version of Linux, because in every new version, something breaks. So it was a huge hassle. You have to make sure the production Linux version is the same as the test Linux version, because obviously you're testing stuff before you release them to the public, right? Your internal stakeholders, your colleagues test those first. How do you make sure the environments are the same? That nobody went into those machines and changed their configuration. How do you ensure that? It's very difficult to get right. That is why Docker is a revolution in computing, because for the first time ever, we have our minds concern-free. We're like, yeah, we have this Docker file. Wherever we run this, it's going to run exactly the same. If it runs on my machine, it's going to run on my test environment. It's going to use 12th Alpine version of Node in production as well. And there is no other software that is installed. Nobody is messing with these. Nobody has even the right to go into these machines and change stuff there, like add new software, update them. It is impossible. It's locked down. So that is why this is a revolution in computing and in how we release our applications, how we deploy our applications. Yeah. Wait, what other questions do you have for us? Another one here.
So my question is, if my application run on 4 different servers, how is it possible to configure Docker to run it on 4 servers, for example?
So there are multiple ways of doing that. And the topic is called continuous delivery or continuous deployment, again. And you automate these things. You identify your servers, and then whenever you create those images, you know, we had that Heroku container release, right? What that release does is it notifies Heroku servers. In this case, if you have 4 servers, it would notify them. Those servers would pull these new images that you have built and then restart the application. So you need to have an automated way of doing these things. Otherwise, you have to manually do it. Nobody does it manually. Every single cloud provider gives you access to APIs that does this for you. So Amazon, Google, I don't know, DigitalOcean, all of them, Microsoft Azure, all of these have ways of doing these things automated, in an automated fashion. And unfortunately, although the concepts are exactly the same, the semantics differ. Like the actual things you have to type and the actual things you have to configure, unfortunately, changes from one service provider to the other. So, you know, this is a full-time job of several people to get right. However, we're giving you at least the basics with Heroku so that you can get started on your own. But if you want to make it more realistic, you're going to have to work a lot on it. Obviously, if you pay for Heroku, it's very simple. Like you can just say, run this on 4 servers, and Heroku does it automatically for you. So you don't have to care about anything. Your commands don't change. But in another environment, it is a little bit more convoluted.
Well, with multiple servers also, there's a term orchestration also come into place.
Oh yeah, orchestration.
Where you put your containers, like
yeah.
In orchestration concept, there's like also another specifications about like how much memory or CPU your application needs, so that orchestrator can figure out, hey, this goes this machine, I can fit 4 containers on this machine, like orchestrate those kinds of stuff. But if there's no other questions about...
Wait, that's not the right way of asking it. The right way of asking it, what other questions do you have for us?
I'm a bit negative about it. Like, I just wanted to... Maybe I just want to, before the question, like, I will have a question, but just a quick recap of what will also come.
Go ahead.
No, please, like, you will have a question, but I just want to give overview. The first part of this class, we just went on deployment, like a crash course, just do it right away thing. And the second part is about how can we do or development so that it's also works on production. It's about, again, the same principle. it shouldn't only work on my machine. So containerization, Dockerization is about that. So if you start developing like that, this way, you don't have to think of, is it going to work on production or not? You already running a simple version of production in your machine. So what production means, like deployed version of your code. So this part, we start with small, how to write Docker file, which is actually the containerization itself. And then we move forward with multiple containers. How do we do stuff? So these topics were planned to be covered in the second part, if we can make it. Yes, question.
Sorry. So we changed the stuff in the codes, and then we pushed like Heroku container push web, and then it was online. Is there a security layer before this? Because usually we have git commit, add commit, and push, right?
Well,
and then now we suddenly have the push and it's online. Is it connected to anything continuous deployment and we didn't set it up yet, or is it the way we're doing it usually?
Kinda. Heroku creates does some kind of magic work underneath. Like it runs Docker when you say container push, and it sends to some registry. They keep your image there, and when you say release, they take this image and put it online. So basically, with the two commands, you have these things happening. About security, like Git also doesn't ensure too much security. It's like obviously with a key authentication, but with Heroku, we also did Docker Heroku Login, and after that, Heroku Container Login, which ensures two levels of authentication. Like first, you authenticate yourself to Heroku, and then Heroku Container Login, which ensures your access to Heroku's container registry. Follow up?
What I mean is not the login things, is when I push something broken. So
I see.
there a layer where I can check before.
Yeah,
before
definitely. That's why actually CI, continuous integration parts come in. In continuous integration cycle, you develop, test, and release, and you get the feedback. You see things are working. So we are lacking automated tested here, and after that, you should trigger your deployment. That's what like best practices are right now. Make microphone.
You can first see that this image works locally, and then that will make sure that it will run in Heroku as well.
So currently there is no automated way of doing it. And this is a one-person show right now. You're on your own machine. You are responsible if it works or not. If you are multiple people in your team, obviously you're going to run into these issues of collaboration. How can you trust that your colleague has the same level of
responsibility,
quality, or understanding of quality as you, or responsibility as you? And that is why we have all of these automated systems, and that is why this is a full-time job to maintain. And we're not covering it in the class. But yeah, obviously, this should work. You shouldn't be pushing to production from your local environment. Never. That's not a good idea. However, it works if you're a one-person team, because that is, unfortunately, the most effective way of doing it. It is like delicious stuff are never healthy. All the healthy food tastes like garbage. And I know a lot of people will not agree, but that is what I feel. Like whenever I want to eat something that I like, my friends around me say, that's not healthy. You shouldn't be eating that. I know, but that's delicious and I want to eat that. This is exactly what happens with these deployments. Like the easiest way to be online is just to push it from your local, just like we did in under an hour. However, that is also not very healthy. That is one of the actual worst ways of doing it. However, it works. If you're a one-person team, it definitely works. And when I'm developing my own applications on my own, I'm also doing it. Like, who cares about Git and pull requests and code reviews and everything? If you're working on your own, you should be doing it.
And also, it depends on how many users you have and how much revenue you make. Like, if they are zero, then you have zero concerns. Like you just push it.
Yeah. Okay, one last time. What other questions do you have for us before we continue?
Don't you have to install
I'll
Mongo
see what I
in
can
the Docker?
Don't we
container?
have to install Mongo in Docker? No, not right now. When we're running our application, you're going to see that it's actually very, very simple to get started with, especially with what we call stock images. Like, obviously, Mongo is not a custom software. It's, it's available on the internet. Someone else built it, and we will be immediately able to use it. That is also the power of Docker. If you have those stock applications, you don't have to install them. You don't have to configure them. It's working out of the box. And we're just going to add 2 lines to make it work with our application. Okay, let's go on.
So, yeah, I just like to address once more about containerization. There were an issue 2 weeks ago where there's a new version of Node.js released. So 2 weeks ago in the class, because there's a new version of Node.js, like Brew is the package manager for macOS. Anyone installed Node.js from scratch had the version 13 of Node.js, and which break our code actually. If I don't know if any of you encountered the same problem here, but this is why we are going with version locking. And just think that you have multiple applications like that. If you cannot upgrade your application to new version of the node, you have to manage different versions. Same goes for MongoDB. Like Arman mentioned, all the kind of these dependencies. So it gets like a dependency hell in your machine. You cannot install everything here. I mean, you can, but it's hard to manage afterwards. With containerization, this is what's about actually. You just add a Docker file, and your application becomes containerized. And there might be some issues when you containerize your application because you didn't run your application in a container before. But if you do it early stages, it will be easy to convert it, and then you can fix mistakes, figure out from the error messages, and then you can move on with a more consistent life. Just everything will be more expected. It's like insurance that your code is going to work when you deploy. So Dockerization itself is not a really hard process. You just write a Docker file and run your application inside it. So we have a Docker file here. I showed how to actually run it. Build it. These are the build images. I'm in front-end directory. I'm going back to backend directory to run Docker build once more. And this dot here represents the directory. So I'm running my build here. So it says successfully built this. I have a hash here, which doesn't make too much meaning, but which is something, an image ID. So I can also see it, Docker images, and grab this. I see that it's built 2 hours ago because this is the first time I built it, and it's the same image. I didn't change in the source code, so we can just go and do it just to see. This is actually generating a different thing. I don't know where to go, but it says hello. I'm just adding a small change here, and I will just build it. Now, opposed to the other build, I have a different hash here. But if I run it once more, I will have the same hash as 08. So it's also giving you like a hash of your application. And whenever you change something, it's a new image now. It has a different identity. And this identity actually allows you to point that image, which will be used with Docker run command. Docker run. And I will use first this interactive terminal. I want to go inside and see what's there. So I built an image, and I want to see what's going on inside that. So I want to run it, and I want to run with a specific command. So I'll maybe not first without it. I'll just do it like this. Just want to run this thing. It's a server listening, just like we run it with Node index.js. But I can't do anything with it. So normally, when we run our application, localhost 3000 should give us something, right? But it's not giving anything. Because containers also allows you to isolate everything. So nothing is going out unless you specifically say, I want this port available. So I can't even also quit. So I have to If you didn't run the process, don't run it because you can't quit it. I'll try to kill it. Also, Docker gives them funny names like this. Docker kill. Sorry, distracted Hamilton. Goodbye. So I killed distracted Hamilton. Sorry. So if you run and you want to quit it, you can close the terminal page too, and you can open a new terminal, or you can. Well, sorry for getting you into trouble, but you have to kill a container. So you can say Docker PS to see the running containers on your machine. I have lots of things running. Sorry about this. But you can see the container ID here, and you can kill it. But compose control, I don't want to kill these. I like these ones, so I'll keep them. But if you want to kill something, Docker kill and the container ID or container name. This readable thing is the name. I don't want to kill it, so just keep them. So what can we do? What else we can do with this image? We can actually run image without running the specified command, which is, where is the Docker file? This command is run by default, but we can also override it. And because I want to go inside, I'm putting -it. It just means interactive, and tmux, like a terminal I'm connecting, and I say sh. So you can run this. But maybe the ID is not that looking good. We can just use other image names for it. So Alpine or something. Let's go back to this. So do you know how to get this ID? Do you know how to get this ID? You can just say Docker build. Let's start from scratch. It will just build it in short time. Copy this ID and say Docker run -it and sh. Can you run this command? Or you just want to watch it? All right. So we are inside our application. I just want to show you files and move on with the next topics. So you see these files are actually our application files. They are in different directory because we wanted them to be inside this app directory inside our container. So it's a new word for our application. The files are living there. And once we run it, they will be executed. So I'm showing you another example. I want to run my container this time with some port configuration. So I want to access the port 3000. If you can follow up, you can't follow up, that's okay. I'll cover up these topics in an easier way. I'll just show this an example that works. So it says server listening, and this time when I go to browser and run this, it gives me hello world. So this time my application is running inside the container and I can access it. But it's the same thing with our first deployment. It doesn't have a database, so when I go to person.all, it just gives, well, right now it doesn't give, but after a timeout, it's giving an error and it will crash.
So it's important to have the command here, docker run -p 3000:3000, and then the ID that actually binds the port and makes it accessible from your computer. Otherwise, there's no way to access that container.
Yeah, because it's a container, you can also specify different port here. So internal port could be 3000, you can just specify a different port. So I just want a different port for my container. It's okay because it's now in the control. And you're running your application with port 3000 inside the container, but outside you can change it. Well, because these commands are not really now user-friendly to write, there's another tool Arman already mentioned about Docker Compose. All right, you can say Docker PS, and you should get a relatively smaller list
of things running.
Yeah, and you can go to the top. No top. Where is the? About a minute ago. Yeah, this one should be my thing. Heuristic one. Sorry about that too. I love these names. So enough killing containers. I'll just quickly show you the front end part of it, and we'll move on with Docker Compose. So front end Dockerfile is not very different from the backend, but it has a different command. So you see, basically these parts are the same, but just the command is a different one. Basically, you also use it for npm run serve, and there are some differences because of the containerization. Normally, you access your server with a localhost. These are just extra details. You can find out Vue.js documentation. If you want to run them inside a container, you just add these things, and then it will work. But in order to run this container, it gets even complicated because now I have to configure a port here, and I don't want to deal with this mess all the time. I don't want to run this long commands of docker run, and I don't know, port. This time it's 8080. I didn't want to go into containerization world just for writing complex docker run commands. So there's another tool for it, obviously, which is called Docker Compose. Yay! So, you wanna ask a question or? Yeah. So because I want to run my backend, and this context actually the dot inside my Docker build command. It goes into the backend directory and runs Docker build command here. It's a build. Like you can. I'm also just copying pasting these files. You don't have to understand every detail. It's about build. I'm building my backend directory with the Docker file. Like it's actually not needed because it's the default one. But anyhow, and this is the port configuration when I give the Docker run command.
The issue here is it is difficult to run these commands manually in the terminal, like docker run -it whatever, that hash and -p. You cannot expect, again, your colleagues to deal with these. This is even harder than running the application with npm install and nodemon index.js, right? That is why there's a better way of doing it. Like nobody, unless you are literally building these images from scratch for the very first time, nobody actually follows this step of building the images and running them manually because it's very difficult. We always use Docker Compose, which is a tool that brings these all together in a very nice way that you can use in your IDE, edit in your IDE, and runs all of these automatically every time for you with a single command. And that is what this file looks like. It works with a file called Docker Compose YAML. YAML means yet another markup language. It's like HTML, hypertext markup language. YAML is yet another markup language. It has its own syntax. It doesn't have curly brackets, curly braces. It doesn't have square brackets or anything. So it's a little bit easier to read and write. And this is how we define our applications, our services. Now they're called services. A backend is a service, front end is a service, and you will probably guess it, MongoDB is another service that we're running in our applications. If you remember my words just like 10 minutes ago, I said running MongoDB in Docker is actually just 2 lines. It's very simple. It is the line 22 and 23 here. You just need to say, I want a service called MongoDB. And the Docker image of that MongoDB service will be Mongo 4.2. You don't even need to write the version. It would still work. You don't need to write the ports. It would still work. Just these 2 lines give you MongoDB running on your machine. Obviously, if you want to access it locally, you need this port configuration. That is why we have the port declaration here. 27017 is the default port of MongoDB. We're exposing to our local machine on this port. So this is called declarative programming. we are declaring that we need this service. We are declaring that we have this front end. It uses that image that is built using the Docker file in the front end folder. You know, it's very approachable if you look at it. If you want to build this image, go to the front end folder, use this Docker file, use these environment variables, view app API URL, so that it knows how to talk to the backend, and use this port in order to start this application. And we also expose that port to our computer. This is a declarative way of doing it. We're just declaring these properties, and the tool Docker Compose takes care of it. And it runs it according to our specifications. We're just giving it the specifications, and Docker Compose just takes it and runs it. Also on the top, we have the backend. The same thing. If we want to build this backend service, we go to that folder, we use this Docker file. As environment variables, we have to give it the MongoDB address, and that is the domain here is called MongoDB. This is the name of the MongoDB service. Let's change that. Let's change that to something else. Let's say something else. You need to update this to something else. So there is a connection already. Like, these services can discover each other. They can talk to each other. That is already automatically built for you. So you don't have to specify further details about it. Yeah, like my Mongo or something. You can type anything there and it's gonna work. This is kind of the magic and the beauty of Docker and Docker Compose. And the important bit is, again, this is declarative. We don't type multiple commands to make this happen. We just write this file, Docker Compose YAML, and probably we only write it once. And then with a single command, if you go to the terminal, with a single command, by typing Docker Compose up, we run this application. That is why in GitHub, you're going to find thousands and thousands of applications that are built with Docker, which have these Docker Compose YAML files. And the only thing you need to do to run them is to clone the repository and run Docker Compose up. And those things will run for you. There is no Docker run -it -p, whatever image name. There is no Docker build. There is no multiple windows. It's just Docker Compose up, because all of them will have this declarative file ready. Now, it is 9:40. Let's get this up and running with Docker Compose up and see that it's actually working in local environment.
So right now I'm in the week 8 directory.
So we're not in the front end or the back end directory. Right now we're in the parent directory. We just type Docker Compose up. And you're going to see that it's, if you scroll up, we're going to see that it's creating 3 services.
So there's front end one, there's
Let's scroll to the very top of the very first.
Backend already said server listing, so it's the fastest one, and then MongoDB starts running.
Can you scroll up?
So just think that how much time you spend actually is trying to install MongoDB.
Wait, this is good. So recreating week 8 backend, starting week 8 front end, and creating week 8 my Mongo 1. So the services that we declared in Docker Compose YAML are represented here. And Docker Compose up either recreates that container for us, or starts it if it's already created well enough to the specifications, or creates it from scratch, from the very beginning, because we didn't run a Mongo image before. We didn't run the Mongo container before. And then you see the logs of each service here. That, MongoDB, this is what you would see. These lines are what you would see if you ran MongoDB on its own. Now it's running in Docker. And when we scroll to the very bottom, I don't know what we're going to see. Is it going to be front end? Yeah. It is what you see when you run front end, npm run serve. Right? It is exactly the same. And any logs that you have in your application will appear here. This is still ongoing. It is an ongoing process. So you're going to see if front end is logging anything. So Now, localhost 3000 person all is working. You know, with a single command, docker compose up, with the help of that docker compose YAML file, we got it up and running. And we are creating a new meetup, a couple of them actually.
And
question.
So this creates a new database. It does not just connect to my old database.
It creates a new database, yes. However, if you stop and restart it, the database won't go away. If you delete the container completely, the database will go away. So that's something to note.
So now all of these 3 services are running, and we see them in action. Also front end, let's get to front end once more. And these are just 2 courses I created just a minute ago, just 3 seconds ago. And you can see that there's some stuff is created here while I created some stuff. So like Arman said, this is a live log of what's happening. All of the 3 services accumulated here. And I can say Control-C, so it killed the containers, but not like the data is not gone. So when I just compose up, it's starting once more. And I'll just have to finish. Okay, I have to wait for finish. Once again, I have the same data. If you want to get rid of them completely, you have to say docker compose down. And you see that it's removing backend, MyMongo, and network, like everything is gone with it. So when you say down, it's gone forever. I mean, your data is gone. When you say up, and if you just want to quit, you can say Control-C or like whatever keyboard shortcut you use for exiting a process. Also, there's another way of doing it. You can say docker compose up -d, it works in the background. So right now they are still running. I can see them. I mean, I deleted it, so
okay. Docker compose down is something we use to remove all of the machines that we have, all of the Docker containers that are running. So it completely eliminates all of them. Correct me if I'm wrong, it also removes the data.
Yes.
So it also deletes the database. So we don't usually use Docker compose down unless we really want to clean everything for good. And then another command is docker compose up -d, which starts it in daemon mode. And daemon means it's running in the background. So you don't see it on your screen, but it's still running. So if you want to say, yeah, run, I don't care, whatever, run always, you do docker compose up -d, and it always runs. And then you need to get docker compose logs in order to get the logs from your application. Otherwise, you won't be able to see the logs. So for your homeworks, we have 15 minutes left. So, and I want to talk a little bit about the homeworks. We're going to give you the docker compose file, and we're going to give you the Docker files. It's already there in the repository, so you already pulled it. You just need to copy and paste them. The first thing that you're going to do is take that front-end folder outside. So you need 2 folders, one backend and one front-end folder in your application. So make sure that the application is in 2 separate folders, backend and front-end, because we're going to create 2 separate applications for them. The Docker files that we will provide should work for applications out of the box. That shouldn't need any specific configuration. Try them. If it doesn't work, ping us. We're going to help you. And finally, the docker compose.yaml, that also should work out of the box without any configuration. You might need to change the database names, maybe. But other than that, that should be fine. You already got started with Heroku. You're going to repeat those same steps within your applications to run your application in Heroku in real life, in production. And that is unbelievably pretty much it for the entire course. JavaScript Crash Course 2019. Women Techmakers Berlin JavaScript Crash Course 2019. This is literally it. everything from the very beginning of defining what a variable is, defining what an object is, that ends with deploying applications to a real cloud environment so that anybody can use our applications. Is there anything we didn't cover that we need to cover still?
I guess not.
Okay.
I mean, well, obviously there will be some questions afterwards if you want to, complete this challenge for yourself.
Yes. So that's actually what I want to do next. The concepts that we introduced today, Docker, containers, production environment, deployment, I know it's a lot of keywords. Heroku, pushing images, building images, it's a lot of keywords. Don't be intimidated by it. You're going to get used to them as you deal with these things. I know it's super complicated and super hard to grasp everything at once, especially when you're hearing them for the very first time today, but that's fine. This is why we're here, and we're always available on the JS Crash Course channel on Slack, so make use of us, ask questions, let's discuss there, and let's take the next 13 minutes to talk about your questions, about the homework, about graduation, any questions you want to ask us, we're here. Also, there's still some reps in the back. If any of you didn't eat yet, or you want to take some for the morning, they make good breakfast, you are encouraged to do that. Who has a question for me?
So I see that in the front-end folder, there is a post-CSS file. What? And I know that post-CSS is a way to divide CSS generally, but is needed only if you declare it and use it, or is needed in general to compile at the end the full front-end application?
Who put post CSS config there?
I have no idea, by the way. Like,
you did? Yeah, you didn't. Yeah, me neither. No, jokes aside, it is a configuration that we usually have in production applications. What we currently use it for is making sure our front-end implementation, the CSS, is cross-browser compatible. It works in WebKit, it works in Internet Explorer, etc. At least some parts of it are cross-browser compatible. You have to install the post-CSS package in order to use it. I think it comes by default with Vue.js implementation that we had. When we had Vue Create front-end application, that automatically came with it.
The style, right?
So the question is, if we have to declare it when we use the style, no, it happens automatically. When Vue sets it up for you, it automatically does prefixes for all of your CSS properties. It's not about compiling the CSS. This here, we only use it for prefixing it. And Vue has Webpack to compile CSS for us. So here, it's only used for prefixing it. If you need more configuration for post CSS, you can also add it here. And it will automatically, there are certain properties where you have to declare it in your CSS code for post CSS to work. You can also have it here. But currently, it's used for prefixing it, and it's automatic. So you don't have to do anything for it. Any other questions? No? Are we all good? Is it kind of do we call it limbo? Like, what's happening right now? There's no ground beneath my feet. Was it all? Curiosity. All right.
I have just a curiosity, because we can use a component and a component Vue.js as an open source, and I was thinking, if, for example, if we make a front end and in Vue.js, of course, and we are making a Docker image we can deploy somewhere and we can use it as an open source?
Depends on the license of the open source library. Open source world is really complicated. There are different kinds of licenses. Some people want everybody to use their code free of charge. Some people say you can only use this in an open source library or in an open source application. You cannot really sell this. And then if the library that you're using has this license, you cannot really use it and make it public. Otherwise, you also have to open source it, the source code. You have to also make it open source. And there are some viral licenses that we call copyleft licenses. Some licenses say you have to open source your code if you want to use mine, and you also have to make it under the same terms. So whoever uses your application also has to open source their code under the same license. Some people like it, some people don't. It is for making open source more and more accessible, although it sounds a little bit evil. It ensures that more and more applications are open source, which is how we believe everything should run. You know, you shouldn't charge for software. But yeah, so there are multiple licenses and you have to check. Most of the open source libraries don't enforce these kind of things. They just say, yeah, sure, just use whatever you want and however you want. Then you're okay if you install it and use it. For example, Vue is one of them. Mongodb is another one of them. And you can use them in your applications. Visual Studio Code is an open source project that doesn't have a very restrictive license. You can use it to build your applications. If it had a restrictive license, you wouldn't be able to use it. So you have to be very careful. Like any package that you install from NPM, you have to check the license. You cannot just use it. I mean, you can use any of them, but you cannot sell the ones that are locked down, that are restricted with their licenses. And not only the libraries that you install, but the dependencies of your dependencies, the libraries that are installed as a result of your NPM install chalk, they are also, you know, they might have restrictive licenses. You have to check them. There are online services to do this for you. You give them your GitHub repository, and then they check if your licenses are good to go, or if you're violating any licenses of any libraries in your dependencies. It is a very, very tricky business to get right. What other questions do you have for us? Are you, like, this is done, right? We're at the very end. There is no more class. Next week, we're going to get together for graduation. Don't forget to bring your friends. Last question.
The last question, because also I was working was, I don't know what kind of CI they had, but when they made push on, they used Bamboo, as I told you. I also use, I had a password to connect to the server. And my question is, when you are deploying via kind of server, you have a unique ID? Okay, this was my question.
Well, there are multiple ways to deploy your app to production, and unfortunately, it depends. I'm not a fan of systems where you have to manually log in and do something on your own terminal to deploy something. As a developer, what you should be doing in the ideal scenario is you're pushing to your master branch on GitHub or whatever tool you're using for source control, and that should signal your orchestrator system that you're ready to deploy, and it should deploy automatically without asking, without any manual intervention. So as a developer, or even as a QA, even as a release manager, all you should be doing is merging some stuff to some branches. Some companies have like production branches. If you merge that production branch, it gets deployed. Some companies have test branches and production branches. You first merge your code to the test branch, it gets deployed to the test environment. Then you merge the test branch to production branch, it gets deployed to the production environment. These things have to be automatic. You cannot afford your engineers to lose time with manually logging in or orchestrating these deployments. It should be as easy as using source control. But this is up to debate. Different companies do things differently. Here at Wayfair as well, we do things differently. We don't do any of what I described here. Every company has their own setup, and you have to work with them. Okay, what other questions do you have for me? The next session is in 2020. We're going to start from the very beginning with the definition of a variable again. And we're going to repeat this. It will be our 4th installation of the matrix. Hopefully, at some point, we're going to break out of the matrix. I don't know. Neo went up to 6, so maybe it's going to be 6 before we break out. But jokes aside, I don't think we're going to make an advanced JavaScript class. Because last time we did it 2 years ago, it wasn't very well received. It wasn't very well received. I don't know if it was too advanced or not. There were certain things that we were not happy with. There were certain things that the attendees were not happy with. So we probably won't repeat it. However, that depends. If you really petition for it, if there's a change org petition, then we might rethink it. Because we're all here, we're just sharing our knowledge. We can do more. Doesn't matter. But if you want an advanced class, the recordings from the first year is out there. It's on my YouTube channel, so you can find them. I'm talking about more advanced topics, not super advanced, but the next level of authentication, security, APIs, further MongoDB queries and stuff. So they're all up on my YouTube channel. So you don't have any excuses. If you want to go on, you can do that. It's out there. Any other questions? No? It is 10 p.m. and the air conditioning is clocked in to stop at 10 p.m. because that is the time we have for the room. But before I leave you, I want to give you a sense of what next week will look like. We're going to be here again. We won't have tables. We will only have chairs. We won't have plugs. So make sure your batteries last. The reason for that is I don't want you to work on your applications during the presentations. We're going to watch presentations here. We're going to randomly ask you to come on stage and present. We might or might not share the order of who's going to present when. Everybody will have 3 minutes to talk about their projects. You cannot go over 3 minutes. You can go under 3 minutes, that's fine. You can prepare slides, you can prepare your code, live demo, whatever. However you want to present it. You don't have to present any code, you don't have to present any running environments. You can just talk about it if you want. But we want to hear your experiences and what you had in mind and what you built. One thing you have to share is the link to your repository so that other interested parties can go in and have a look at your applications, your code. And we have a USB-C to HDMI converter here. I will ask you to bring your own adapter if you have a different output. We have HDMI connection here. We don't have VGA. So from your computer, you either need an HDMI cable out or a adapter to HDMI. Make sure you have that. We're going to bring a couple here that are very common, and we will try to make sure you have those. If we don't have that, you can use our own computers. We will bring our own computers here as well. Apart from that, bring your friends. Since there's going to be chairs here, we can accommodate a couple more people. I think we can accommodate up to 100 people here in this room. So you're free to bring your friends, but make sure you to mark them in Meetup as +1s or +2s, whatever, because it's all about celebration. We are pretty much done with the course. By next week, you're going to be done with your homeworks, and we're going to celebrate. We're going to have prizes. There is one Google Home Mini device that I have. We're going to have certificates. We're going to have a little present from us for you so that you remember us in the future. Hopefully, we'll have much bigger impact on your careers, so you will not need to look at that little present to remember us. But as a token of love from us, you're going to receive a little present. And there are, again, 2 internship positions that will be open after the course. And we're going to announce it on our channels as well. But you'll be able to apply and run through real interviews. And hopefully 2 people outside this classroom will end up in Wayfair and UNU as interns for 6 months. And hopefully it will be turning into a full-time contract. The organizer of this course, Celia, is over there. She was a student in our first JavaScript crash course. And as you all know, she is working at UNU. Maria, if she's here as well, she's also one of the graduates of JavaScript crash course, working at UNU. We're continuing that tradition within Wayfair as well. So we're going to have 1 internship out of this course. We believe just by demonstrating what you have learned here up until this point, you will be able to secure internships or even junior positions in companies. So keep us posted with your success stories, like the contracts that you sign, the places that you apply. And we're more than happy to support you with anything you need in order to get these done. Enough talking. If you have any questions, please come to me afterwards. We're going to see you next week. Thank you.